Hello. So we are going to start with a new project, which is scaling web app using application load balancer and auto scaling group. This is the new project. Let's write the project description for this project. This project involves deploying of the web application using EC2 server. Then it is layered by auto scaling groups plus a combination of load balancer also to distribute the traffic. So we are going to test various load balancing strategies, and we will be putting some load on the EC2 server that will be in turn increasing the CPU and the memory utilization on the individual EC2 servers. And finally, it will be used as the input metrics for the auto scaling groups, scale the number of the EC2 instances. For example, if we need to do scale in or scale out, that we are going to see directly in this project. So in this project we are going to use EC2, ALB and auto scaling groups to deploy our web application, and we will be doing a load testing of our application. So the very first step, number one, is launching to web server and testing. Okay. So for the very first step, number one would be launching the EC2 web server and testing the web app. So the very first step is first we are going to launch our EC2. As we already know how to do it, we will be just not writing each and every step, just directly going to the panel and launch the EC2 server. So this is the panel. We will go to the EC2 page. Okay, go to instances. In the instances, we are going to click on this button, launch instances. So this launch an instance page will open that will help in creating a EC2 server. So we will provide a name as web server. You can also write HTTPD. We are going to use HTTPD service. We can use the Amazon Linux. E3 micro is fine. For the key pair, you can create a new key pair with the name which you like, and click on create key pair. So your key will be downloaded and saved in your local laptop. Then comes to the networking settings. Everything will be default. We will be creating a new security group in which port 22 will be open, and the storage will be of 8 GB. That is sufficient for our testing. So just revise it quickly. So first we have provided the name of our server. Then we selected the operating system as Amazon Linux. Then the instance type is selected to be as t3.micro. Key pair as web server HTTPD key. Networking settings, we keep all the things default. For the storage configuration, we have provided 8 GB of storage with the GP3 type of storage type. So GP3 is one of the storage type. If you want to have the IO input output operations to be optimized, then we can use IO optimized EC2 storage type. But our work would be done with the GP3 only, so we are going to use that only. Then finally we click on launch instance. So our instance is created. Let's go to the instances page. Okay, so this is we will wait till the initializing is being done. So initializing is just like a health check for the EC2 server, whether it has completely booted up or not. So these are the few details page in which a public IP of the EC2 server is there. So this is the globally accessible public IP. Private IP is the internal IP of the EC2 server for internal communication via VPC, and this public IP will be used via internet gateway. And the information which is required is t3.micro, which we are using, instance type, and that is it. Our storage is of 8 GB that we have selected in the form. Our security group, which is like a firewall for our EC2 is server, that is that has opened only the 22 port from the internet. So this is the anywhere IP 0.0 is the anywhere IP, so that we can use it to open the traffic towards the internet. Basically, it involves all the IP addresses in the range. Just refresh this page once again. Okay, so we click on this connect button. Click on connect. If your pop-up is blocked, just okay, click on allow and done. Then click on connect once again. This will open your like a console to your EC2 server, where you can configure your EC2 server using the CLI. So this is the Amazon Linux page. What we are going to configure, we are going to configure a web server which is HTTPD. So first we will be doing some updation. using sudo yum update, because this OS AMI which is running could be of old configuration, so we are just going to update the configuration using sudo yum update command. This will fetch the latest repository. Once it is done, then we are going to install httpd as the service. Okay, so we will check the status of the service, sudo service httpd status. So currently, what we are seeing, the service is inactive. Let's start the service. So HTTP service is started. Then we check the status again. It is in active state running, and then we can enable it also. So why we are enabling this service? Because when any EC2 server is restarted, it will restart this service or start this service after completing the boot of the operating system. So if we do curl localhost, this is the page which is getting loaded. So HTTPD is generally the web server which loads the HTML or an HTML or any web page. So where this web page is located, it is located at a location which is where. Then we go inside www, then inside the HTML. Okay, this is the location where it is serving the web page. So this particular, if we edit it, or first we try to load the IP in our browser, copy this IP and put it under the browser using HTTP to call. So as the port HTTP is not open, we need to go to the security group and open the port 80. Click on edit and bound rules, add the rule, open the HTTP port, IPv4 and click on save rules. Once the rules are saved, just refresh this page once again. So it will be showing it works. So that is the same thing we are seeing here. Let's try to edit this file. So we have added just this line, and we go back to our browser and refresh this page, so this content is updated. So what it means, like that, it is the live updation of the content of the web server. Okay, so this is the basic idea behind the using of our web server. So we are going to host this web server under the load balancer and see its functionality. If we see the current working directory where it is storing the index.html, this is the thing which is needed to be seen. Okay, so now what is the next thing what we are going to do? We will be creating a AMI of this web server, and we will be testing the application. So let's edit once more. Then we create the AMI. We are editing the index.html file. So just we write the project name, and then we refresh this page. It will be the same thing as expected on the public IP address that is being shown here. So what we have done till now, we have created web server. In this web server, we have installed the HTTPD service, and after installing the HTTPD service, we edited the index.html file, and in that index.html file, when post updation, it will be when we search the public IP of our EC2 server, we are seeing the updated content of the index.html. Okay, so what we are going to do next here is we are going to allow uh, launch template to use this thing. So these are the steps we are going to do next. First thing is launch the EC2 server. After server is up, install HTTPD service and edit. What is the location? Let's put this location also. So now after EC2 server is up, install the HTTPD service and then edit this file. This is index.html that is hosting the web application. Now the next step here is we are going to use this server as the template, and we will be launching the auto scaling groups and load balancer using that thing. Okay, before moving ahead, what we can do here right now here is our next step is stop the EC2 server and create AMI of our web server. So what is AMI? AMI is like a exact copy of the REC2 server that will contain all the latest data that we have made any changes. So our step number 2 is creating AMI. So our step number 2 is creating AMI of the web server. In the creation of the AMI, first we go to the instances section and stop this server. Go to this instances section and click on instance state and stop the instance. Wait till the server is getting stopped. Then we will start creation of the AMI using our stopped server. Till it is in stopping state, we will wait. Once the server is fully stopped, then we will create the AMI of this server. So it is like a copy of the server and which is in the stopped state. Yeah, once the server is in the stop state, we are going to create the AMI of this server. So to create the AMI of this server, we click on actions, go to image and templates, click on create image. We will write this name what we have this for our server like this, and we can also write AMI. In the description as well, we can write the same name, what is the image name that we have provided. Then we finally click on create image. So it will create the whole copy of the image that we have stopped using the server that we have stopped. It will take some time to create the AMI because it is copying all the contents and all those stuff in the new image. It will take some time to copy, and once the copying is done, it will be in the available state. So this is the process of creating the AMI. It is very easy. Just we need to make sure that server is stopped, else you can also create AMI on the running server, but it will impact your changes. So generally the process we follow is to first stop the EC2 server, then create the AMI, so it would not affect any last moment changes that your server is making, or any service, or the last moment service it is making, and that could impact our further configuration. So we just follow this process. First we stop the EC2 server, then we create the AMI. So we are waiting till the AMI is in the pending state. Okay, now it is in the available state. So it means that AMI we can use to create another EC2 server. Let's create another EC2 server using this AMI. Now we go to the instances page and see whether our old server is running or not. So it is not running, as we have stopped the server already. Then we go to the AMI's page. Go to the AMI page. Click on launch instance from AMI. Select the AMI and then click on launch instance from AMI. So once we click on the launch instance from AMI, the AMI that we are going to use will be pre-selected at this page. Okay, as you can see that AMI catalog is been updated with our AMI that we have created. The same process we are going to follow. Web server, HTTPD. Just we are creating a new server, and all the things we can keep the same. Key pair, we can also use the same key pair. And finally click on launch instance. Once the instances is created, we go to the instances page once again and refresh this page. So one of the server is already running, but this time you will be seeing that we are not going to install any HTTPD service. We select this server, get its public IP, put it under this and search for it. Though we have not enabled the port number 80, we are going to enable this thing also, because this is the new security group which is created, which does not have port HTTP open directly to this EC2 server. Or we could have utilized the earlier security group also, but we will be adding port 80 from any source to the security group, and then finally refresh this page. Check once again if you are only accessing it using HTTP. If you still find your server is not running, it could be your web server which is not running. This could be the thing, that is why we are not getting a response from our server when we are searching any public IP to our server. So we just try to connect to our web server and see whether our application is that service which is HTTPD is running or not. Let's check it. Sudo service HTTPD status. Okay, our service is inactive, so we need to start our service and enable it also. And finally, when we refresh this page, this is actually gonna work. So we have fixed this thing, and what is the next step? What we are going to do? We are going to create a launch template. We are going to create a launch template of our application that will be used by our auto scaling group. Before that, let's do a thing also. Okay, let's. Okay, now the service is enabled. Earlier it was not enabled. So next thing what we are going to do, we are going to start our old server also and test the load balancer setup that we are going to implement for our web application. We start both the servers. After creating from the server, launch another EC2 web server using that AMI test. We will wait till both the servers are up and running. Okay, we will copy this public IP also, paste it here. This is another public IP. This is another public IP. So we log in into both the servers. So let's wait when the screen is loading. So yeah, we are inside the server and let's see the HTTPD service. Okay, it is active and enabled and running. For another web server, let's see that the same thing is running or not. So this particular thing is running. I suspect this is not running. That is why we are not getting any response. We go to another web server. Click on connect. Okay, let's see whether the service is running or not. Sudo service http status. It is not running. So we start the service. Sudo service httpd start, and let's refresh this page again. Okay, now it is working. So both the application is working. So to differentiate it, let's edit its individual index.html file. To edit it, we need to edit the file location, which is at user where httpd no index, and this is the index.html, which is getting. So let's edit this file. Let's write server 1 maybe. This is 47. I just let me refresh this. It will be server 1. Let's go to the same location on the server 2. And refresh the another page. It will be server 2. So let's put this both the server under a load balancer and try to test the load balancing setup. Then we finally move to the auto scaling group. So till now what we have done, we have created the AMI out of it and create the new server of using that AMI. Now we are going to configure load balancer. Let's wait for some time and then we start again. So till now what we have done, so we have created two servers hosting two web application, which is coming from the traffic is coming from server 1, another traffic is coming from server 2. These are the two web applications which are running. After that we are going to create two things. For configuring a load balancer, we need to configure the target groups and we need to configure the load balancers. So it will be divided into two steps. First one would be creating target groups, then creating load balancer. So the load balancer we are going to use is application load balancer. These are the two things which we are going to configure. The first one would be creating the target group. So what is a target group? First we will going to see that. So target group is the group of the application servers or any endpoints where the application is running and you want to use those endpoints or to group them so that it can be consumed by the load balancer to forward the traffic to those endpoints. So this is the basic requirement of the target groups. It basically groups the endpoints or any application servers or any IP address so that the load balancer can forward the traffic to that particular IP addresses or endpoints. Let's start with creating the target groups. Okay, so we are going to create target groups. So for creation of the target groups, we click on target groups. Then we click on create target group. Our target type is of instances. So we are going to select instances as our target type. So it could be either the IP address as well, or the Lambda function, or the application load balancer itself. So we are using our endpoint or the end location where the application is running is the instances. That is why we have selected the instances as the target type. Target group name, we can provide the name as the same thing, web server httpd target group. So the protocol for now, what we are using is HTTP only. That is why we are going to select it as a HTTP. If you are going to select as HTTPS, then it is also the option. Other options are TCP, TLS, and UDP also. But we are going to use HTTP as the option for now. And the health check is the one which we are going to use it on the traffic port, on the same traffic port. Why? Because particularly our application, which is a web server, which is the HTTPD web server, as we know that it is running on port 80. That is why we have selected this thing, and the target group name is the same thing. Then is the name, then the protocol what we are going to use for the communication between the load balancer and target, it is 80 port. And the health check protocol is also HTTP. Then we click on next. These are the two load balancer these are the two EC2 servers which we are going to add it as our target groups. Then we click on include as pending below, and finally click on next, and then finally click on create target group. So this is the process of creating the target group. Then we are going to follow the next step of creating the load balancer. Go to the load balancer section, click on create load balancer. We are going to create the application load balancer. So application load balancer is used for HTTP and HTTPS traffic. Network load balancer is used for TCP, UDP and traffics, and gateway load balancer. That is a separate talk because it works on the different OSI model layers of it. Is works at the application layer, it works at the network layer, it works at the transport layer. So these are the different layers that we need to think of, but for now we are going to create the application load balancer. Now we are going to create application load balancer. To create the application load balancer, we will follow the following steps. So the first step is load balancer name. Let's write it as web server HTTPD ALB. This is internet facing, IPv4 as the address. Network mapping, it will be, you can use the same thing. AZs, you can select the two AZs. Security group, we can select the default security group. Then in the default action, we are going to select our target group. And that's it. What we have selected, let's see those things once again. So we have written the load balancer name, which is web server HTTPD ALB. Then the scheme is internet facing, or it could be the internal as well. Then is the network mapping, the availability zone selection, in which availability zones for high availability. Security group is this one, and the target group selection. Finally, we click on create load balancer. So it will take some time to provision the load balancer. And once the provisioning is done, it will be available state. It will be changing to available state. So let's do few configuration, like the security configurations for our load balancer. If you are seeing this security group, let's open this security group. So this is the how our traffic would be moving from the user to the our application servers. It would be starting from the user, then going to the internet gateway. From internet gateway, it would be going to the application load balancer. From application load balancer to the target groups. So above the application load balancer, there is a security group layer. Above the each EC2 servers, there is a security group layer. So there are two EC2 security group layers are there. So at the security group which is attached to the load balancer, we are going to allow AT port only. So we are going to allow HTTP port from anywhere. So this will allow the security group for our for our application load balancer. Then comes to the instances part. And these are the two individual security groups which are there. Okay. So currently, AT port is open from any source in both the security groups of the EC2 servers. We are going to change it from the source to the application security group source. Currently, it is allowed from all the sources. We are going to restrict the source from ALB source only. For that, first we go to the security group pages and see what are the security groups are there in our system. So these are the security groups which are there. So let's try to find out first our load balancer security group ID and add some tags like name to it so that for proper understanding. Yeah, you can say that, see that the load balancer is in the active state, so we can start using that. Before using it, now we will see the target group. So what it is saying, target is an availability zone that is not enabled for load balancer. Okay, target might be in the. So we what we need to do, we need to do some configuration as well. We need to edit the subnets. We need to select the subnet C. It could be the chance that one of the server is in the subnet C, and then we click on save changes, and we will come back to our security group. This is the load balancer. Then click on security. This is the security group, which is ending with 9FC6C. This is the one. Let's name it as for now is web server httpd ALB security group. So this is attached to the application load balancer. Then our individual EC2 security groups. One is launch wizard 2, another is launch wizard 1. So these two security groups are for our web server. So what I do, just write the name web server httpd security group. Click on save. Similar name. Okay. So first we are going to select this web server httpd ALB security group, or you can select this thing and go to the inbound rules, click on edit inbound rules, and select the ALB security group as source because it is not aligned to. We need to delete it, then add it again, HTTP traffic, and source as ALB security group and save the rules. So one of the application would stop working, yeah, because it has not been out from the internet anymore. Coming to the launch wizard 1, we are going to follow the same process for this also. Edit inbound rules, delete this HTTP one, add the new HTTP, add the ALB security, click on. So our currently flow would be something like it will be the traffic will be first coming to internet gateway, then going to a load balancer. So it will be having a check at the ALB security group. Then individual HTTP security group, which is the EC2 security group, will handle those things. Okay. Then comes to the load balancer. Let's go back to the load balancer and select the load balancer, resource map. So what it is saying, health check failed with these codes 403. Okay, now let's try to find out why the health checks are failing. Open the target groups. So it is saying that health status is unhealthy, and it is saying 403. Let's go back to the health check routes. What we are checking? So we are checking HTTP traffic on this path. Okay, so this should be something like the health check problem. Before investigating that, let's first try to copy this DNS name and try to search it on the internet, our load balancer thing. It will be reachable on HTTP. So it is showing some result, and both the servers are receiving the traffic. So the question here is why ALB health check is failing. So it could be because the health check route is not configured on the system level. This is one of the reason for unhealthy check routes. So what it is saying, it is failing with failing with resource not found, kind of some unhealthy status. Let's try to investigate for using this thing. Because our load balancer setup is working, so it is just the health check which is failing. That is most important thing, because in the auto scaling group, when we try to establish the things, we want the health check to work properly. So we try to fix this thing. First we try to see what are the problems could be there in the health check. So we find that it is the protocol is HTTP, and port is also HTTP. So we are using traffic port, which is also correct, 80, and success code is should be 200. Let's go to the server and see whether we can see something or not. Let's try to see in the HTTPD logs. Then we try to investigate. So our only issue is this target group is showing healthy. It should be showing healthy, but because of some configuration or something, it is showing unhealthy. Let's try to fix this thing. Let's go to one of the server, go to the location, see where log, go to HTTPD. So though we are seeing health check route, but it is returning the 400 response code, but it is responding with the investigate why it is sending 400 free to our health check route. That is why it is not working. Okay, so the issue was that particular file is not existing in the location where it should be. It should be in the HTML where www location. So just we put it once again here and restart our service. And we try to analyze the logs. Okay, it start getting the health check as okay. We have restarted both the HTTPD service and try to refresh it once again. So this is working, and let's go back to the load balancer and refresh this thing. Yeah, one EC2 is healthy and another one would also be healthy after some time. So what we have learned here is that there could be some different problems with the health check routes, though your application could be receiving the traffic, but it could be the chance like health check routes need to be proper established in the application server so that any ALB which is there right in front of the your application server could do the health check. Now both the EC2 servers are marked as healthy, so this is very important thing that is needed to be noted. Okay, so till now we have completed the configuration of the load balancer and this configuration. Now we are going to start with the configuration of the launch template, and we will be doing it from scratch again. So we will be just closing everything and deleting all the stuffs. First we will go and delete the load balancer. Then we delete the target groups. Total load balancer and target groups are getting deleted. We are going to put instances into the terminated state that is not required anymore because auto scaling group will be creating the instances of its own. So we will be directly terminating the instances. both the EC2 servers we are going to terminate. After that, we have created a AMI also, that is also not required. It was just to show how the AMI can be created and how the complete EC2 server can be copied. So that is also we can deregister it and delete its associated snapshots also, so that you cannot should not occur any costing. Then finally comes the security group portion, where the security group must be lying. We delete all the security group except the default ones. This we change the name to default security group. So once instances are completely deleted, okay, both the instances are completely terminated, we can delete that security group also, which is associated with that server. So we have deleted all our target groups, load balancers. Key pairs we can keep as it is. Load balancers are also deleted. Target group is also deleted. Volumes, let's check if any volume stale volume sometimes left behind. If not properly deleted, it will be causing the costing. And snapshots also we need to check. And rest of the things we don't touch, so we don't need to worry about the rest of the things. Okay, so for now what we have done till now, we have seen how the load balancer is working, how the health check is getting configured, how we created the AMI. Now we start the actual work to create. First we will be creating the launch template, so for our EC2 server. So what is the launch template? It is that form which you have seen when we launch any EC2 server. That particular form which you have seen is actually the launch template, but it is not it is a separate configuration file. But yeah, we can consider that as the launch template as well. So it is just like the configuration file where all the configuration is stored, and you can use that configuration file to create your own EC2 servers. Okay, so first we will be creating the launch template. Creating a launch template. Create a launch template, we go to the template section, launch template section. As you already know, what we are going to do, we are going to create a configuration file, that the things, all the things what we have done. So let's write the steps once again. First, we need to go to AWS console, then to the EC2. then to the launch dates, then we will click on create launch. So this is the very first step we are going to do. First we go to the AWS console, then to the launch, then we go to the create launch. So just click on create launch template. Form which is similar to, you can say that our EC2 server will pop up, but requires some additional things also that we need to provide, but almost it's the same thing. So launch template name, we will be writing the launch template name. So let's write some heading. Configuration, what is required. Very first thing what is it asking is launch template name. Let's write the launch template name is scripts httpd template. Description we can write this. For application OS and images, we are going to click on quick start and select the uh, Amazon machine image. Next thing what we are going to select here is instance type. We can put it as search for t3.micro. It comes under the free tier eligible. Then we select the key pair which we have already created. Next thing is networking settings. You can include any subnet which is not required. So, but the security group we are going to create it dedicatedly. So we are going to write web server HTTP security group for all our EC2s which are launched from this template. Now we just update the security group also. In security group rule, we are going to allow HTTP traffic from any source. Also, we can have SSH also. Anyway, EBS volume, that is fine. 8 GB volume is. Finally, we click on create launch template. Network settings. So you would like to do data security group SSH from rest all default. Finally, click on create launch template. So this particular is click on create launch template. So we have created the launch template and we will be moving to the next step of have you seen any versioning of any launch template? Yeah, just I forgot that thing. So we can have a versioning of also the launch template. Which version of the launch template you would like to use? So let's assume that yeah, we need to change the configuration. How we can change the configuration and make it use? So first we see that what is the template we have created. This is the template we have created, and here we have the versions of the template. So version 1, version 2, version 3, these are the versions which is there. So we can maintain the default version is one which is latest selected. We can have the multiple versions and use those versions for our use purpose. So application load balancer can, or the auto scaling group which is going to use it, can select this template and start creating the EC2 servers in event of auto scaling group triggering, like the heavy load is there. So we are going to see those things as well. So we are going to create the new version of the launch template. So we are going to create a new version. So in this new version, all the things would be same. As you can see, all the details are pre-filled, so we don't need to worry about the details, but we are going to update the things which are needed to be updated. So the most important thing is that is needed to be updated to update the installation of HTTPD service that we are going to use it. So we are going to use HTTPD service installation process that we have used. So in the user data, we are going to write the script, which is something like this: a bash script sudo yum update -y, then sudo yum all ppd -y, sudo systemctl start httpd sudo systemctl enable httpd. Then we finally echo our HTML contents, which is between the tags. We can write this project name. Okay, and we need to write this content to the location as where www html dash html dash index.html. So this is the script that will be running on the start of any EC2 server. So when any EC2 server is launched, this particular script will start and do the installation of the HTTPD service, then enable it and then start it and then update the HTML file in the appropriate location. So this is the process. Let's click on create template version. So it will create the new versioning of the template. So this is the thing which we can do in multiple versions. If you forget to add the version of any content, you can make it use it, and we can set it as the default version. Click on set as default. So when any new configuration or any new launch template or any auto scaling group is trying to launch the template, it will use your latest default version. So using this template, we can launch the EC2 also. We can select the launch template, launch template version is the default is to 1, which we can select that, select the default template version. So it is like the configuration file saved by the AWS to refill the data of any EC2 configuration that is we are going to launch. It is the pre-filled form. It makes the thing simple. We can have multiple launch templates. We can use that, but this is the one thing we are going to see. And if we click on the launch template, so launch instance from the template, it will launch the instance. We will wait till that instance is getting up. If you see the configuration of the instance, it will be exactly same as mentioned in the template that we have created. If you see this thing, security group also, it will have the same security group auto assigned to that system. We copy this public IP and search for this IP. So we need to enable the traffic on HTTP, where it goes to HTTP. So we have to wait some time to script to run and install the HTTP service, and then we can make sure that it is whether it is working or some issues are there in the system. As our application is not getting up, we need to check what has actually happened. Maybe we need to wait some more time to make this thing. So let's go inside the EC2 and see whether our HTTPD service is installed or not. So our HTTPD service is not installed actually. So our service is not installed, so there must be some issues while creating the EC2 server. Let's try to investigate once more. As our application is not coming up, it is indeed meaning that launch template is not correct. We go back to our launch template and see whether what could go wrong. So when we click on this actions, we click on launch instance from template, we get an overview what is going to be installed or something that is needed to be there. We select the default 2 version that we have latest updated it. The advanced details, all things are looking fine, but I think the script is not running. That is why HTTP service never installed on the system. Let's check what could go wrong. First thing which is just bin bash needed to be updated. Then sudo yum update minus correct, sudo yum update httpd minus process mctl start httpd correct. So this we need to update it once again. We go back to our launch template, modify template, scroll down to the user data section, click on advanced details. And we update the script. So now we have 3 versions. And make it as the version number 3 as the default version. We can stop our old EC2 which is running. We will use this launch template to launch one more EC2 instance and then see whether this time this works out or not. Then we click on launch instance once again. We copy this big IP, put it here. Okay, now it has come up. It was that shebang line issue, I think so. So we have created the different versions of the launch template and our EC2 is also working fine. So we don't need to worry about our auto scaling feature too. If we scale it using this template, it will be going to work fine. So the next thing is we go back to our system. We can terminate this EC2. Now we are going to create auto scaling group. Before creating the auto scaling group, we are going to attach load balancer. So first we are going to create the application. So creating an application load balancer. First we go to E2, then we first create the target groups. Then we click on create target group. First we go to EC2, then target group, then create target group. So target group name, put it as web server HTTP target group. Target type is instances, target group name. Then we have protocol as HTTP and port as 80. IP address type is IPv4 and VPC we are going to select all, we are going to go with all the default version. Rest all are default. Click on next, click on create target group. After creating the target group, once the target group is created, we go to load balancers and create load balancer. In configuration, so load balancer name web server http ALB. to create a auto scaling group. We go to auto scaling group. Create auto go to auto scaling groups. Create auto scaling group. Auto scaling group name. Then we select the launch template. And default version is 3. As you can see, we have already tested this template, so this template is working fine. We can use this template. So let's go to in this we select all the AZs. So select all the when we go to this page, we are going to integrate the load balancer. So we click on attach an existing load balancer. So after choosing your already created application load balancer, we turn on the health check. After turning on the ALB health check, I think all the things are covered. We go to the next page. So here the things are important. So desired capacity, we place it at 2. Minimum is also 2. Maximum we can go with 4. So the target, there are two types of scaling policies. We can use no scaling policies or rather the target tracking scaling policy. So for now, we are leaving it as all default. If you select the target tracking scaling policy, it will be depending upon the CPU utilization. So we are not going to select this thing. For now, we are going to go with the no scale. Then post that we are going to see this thing. So for now in this page, select the minimum desired capacity, max desired capacity, and rest of the things should be default. Max desired capacity is 4. Also, then we finally click on auto scaling group. Create. So it will take time to do the changes. Let's wait till the auto scaling group is getting configured. First, we will be seeing the instance management. Okay, it has already started the 2 instances and its version is this one. Automatic scaling We have not set it up right now, but we are going to set it up. Then we go to the load balancers also and see whether mapping is done or not. Okay, mapping is completed for this one. Wait for some time, this will also come up. See, we select this DNS and try to search it on the internet. Okay, via ALB we are able to reach our application servers. Okay, now let's wait till the capacity planning is doing its things. We have already seen these desired capacity has met. Okay, both our targets are healthy now. So once both our targets are healthy, we can do some testing with the load balancing thing. For that, first we need to set up the policy. So automatic scaling policy we need to set up. So we have a dynamic scaling policy, predictive scaling, or the scheduled action also. Now we can go with this dynamic scaling policy. In this we have step scaling, simple scaling, based on like CloudWatch alarm. We can have the simple scaling, step scaling also with based on the CloudWatch alarms to increase the number of EC2 servers based on step approach, or target tracking is also there, in which the target which is there is tracked on the basis of average CPU utilization on any custom CloudWatch metric you want to target. So let's do this thing. Instance warm up time default, if you check this thing, it will be the default time which is needed to be provided. So by default it is 300 seconds. We can keep as it is, or we can lower this value so to get 50% is also correct to test the things. Then we click on create. Now we are going to test the auto scaling group. So to test auto scaling group, so we are going to use Apache Benchmark to do the load testing. It is like a A/B testing which we can do. So to install it, we need to get this tool. to run a server. That will be more easy. Which name is as A/B testing. Ubuntu we can use. For the create key pair, we can our own key. Security group SSH is only required. After launching the instance, go to the instance. We are going to increasing. We are going to run AB with the request 50 to the endpoint. So we manually store server is it when we then for this project. Okay, let's connect to our A/B testing. So I think AB command is working. So Apache Benchmark is installed now. We copy this and so I don't think it will put a stress on the server. So A/B testing will be working fine, but it will not put any load on the server because it is not like that. Just what we can do, we will be installing a package called stress that will put the stress on the server. So we are going to stress the timeout for 600 seconds. put the same amount of stress on both the server, and let's see whether our CPU utilization is going up or not. Okay, stress is doing its thing. Go to our auto. Now we are seeing sudden increase in the CPU utilization. So maybe after time auto scaling will trigger. Go to the, we need to wait for some time, make it work. For A/B testing one, it is not required. So cut that out. Yeah, so we have terminated the A/B testing server. So only thing which is pending it is verification of scaling services. Then we can wind up our project. Okay, till then we can write the summary. We have set up Apache web app thing group. So we have achieved scalability, like the scaling group, done. You can see that what we have achieved using this project. So we have tested the web application, which is highly available. Web app using ALB and auto scaling groups. We have achieved scalability using scaling groups. We have achieved multi-AZ deployment. We have how to create AMI rates. We have configuration of load target group. Okay, we are seeing scaling now happening. So go back to our auto scaling group. Desired capacity has gone to 4, and instance management has scaled the instances to 4 count. Successfully tested auto scaling group uses theory by putting this 8%. So when this thing which is running, currently it is on the 96%. So we have run it for 600 seconds, which is 10 minutes. After 10 minutes of CPU load, it will stop all the instances that we are going to check. Once the instances are stopped, we are going to terminate all the projects that we have created. All the resources we have created, it should be terminated so that we don't occur any costs for doing this project. So at a time now, 4 EC2 instances are running. You see the running count, it is coming to 4. So we have seen this thing and we have completed this project number 4. Now the next thing would be another project, but before that, we will be terminating these resources once the testing is completed, and we will be get back with a new project. Okay, I'm just winding up this project, and we see you in next project.